Hello guys, so today we are going to discuss this problem, graph valid tree. So the problem states that uh, we have a graph um, which has n nodes labeled from 0 to n minus 1. Please note that nodes will start from 0. And we are given an integer n and list of edges. So edges are like ai and bi, indicates there is an undirected edge between node a and bi. So we have to find that um, return true if edges of the given graph make a valid tree. So maybe we can think of this problem as it's whether it's a valid tree or not. For example, this is a valid tree. So node 0 has 3 children, node 1 has one children, which is 4. And how the relation is there, we have edges from 0 to 1, 0 to 2, and 0 to 3, and there is an edge from 1 to 4. So output is true. While in this case, this tree is not valid if we consider 0 as a root node, 1 as a child, then it has two childs, 2 and 4. But again, there is a cycle, that is, there is a cycle which is there. So it's not a valid tree. So we return false here. So how we are going to approach this problem? So basically, this is a graph problem. Uh, and from the given edges, first we have to create a graph. Um, After creating a graph, we will look at the disjoint set. For example, let me take my notepad. Okay, so for example, if we have a tree, something like 0, um, 1, and 2, and we have, uh, since graphs are trees also, and we have some nodes as 4 and 5. So this is not a valid tree, right? And this complete graph has two disjoint sets. So one disjoint set is this one, and another disjoint set is this one. So we have to first find. So there are two conditions here. I'll just write it down. So one is find whether there is any disjoint set or not. So if there is any disjoint set, that is number of disjoint sets is greater than 1, so we have to return false. Second condition is we have to find a cycle, find whether uh, there is a cycle in which type of graph this is. This is an undirected graph, right? In undirected graph. So if there is a cycle, then again we have to return false. So basically, I'll not go into much detail that what's the difference between directed, undirected, and that stuff. But in directed graph, we'll have edge pointing to um, we have a direction in it. So if this might be a if this was a directed graph, then this edge will have a direction, that is only we can travel from 0 to 1, something like this, and we cannot travel back. But since this is an undirected graph, sorry, so both nodes can travel from 0 can travel to 1, a person from 0 can travel to 1, and a person from 1 can also travel back to 0. So both directions are allowed. So this is the only these are the only two things which we are going to need, and definitely that's with that we are going to solve the problem. So where it is, okay, valid graph tree. So let me jump directly into my GitHub where I have all things explained. So the approach is we are going to find whether there is a disjoint set or not, and whether the graph has a cycle or not. So first we are going to create a tree. So how I'm creating a tree is with an ordered map. So for example, I'll take this one only. So let me copy this. So how I'm creating a tree. So I have an ordered map in which key is 0 and value is the number, all the nodes which are connected to 0. So value will be 0, 1, and 3. So it represents that 0 is connected to 0, 1, 2, and 3. Then for one key, I'll have the value as 0 and 4. Then for 2 in the unordered map, I'll have value as 0. And then for 3 in an unordered map, I'll have value as 0 again. So how I have created is I have taken, so I'm just referring it in C++ terms. Um, in Java, you can take it as a hash set. So I'll have an ordered map int, and I will take an ordered set of int. So I'm taking a key as a node and value as an unordered set, which represents all its neighbors. So the number of edges which a node will have will be equal to the size of its unordered set. For example, node 0 has 3 neighbors, so it's 3. Then again, node 1 has 2 neighbors, so the unordered set size is 2. Very simple, right? So how I've created the tree. So as the question says, um, from main, we'll be calling this valid tree. From valid tree, I have uh, called this class constructor. This is graph. So to graph, I have passed the edges. So edges is a vector, two-dimensional vector. So let me go into here, and please pardon me, I'm directly jumping into the code because that will be easy to understand. So this is an ordered map. Um, okay, I have taken an ordered map of vector. So this is a graph. So I'm just calling graph here. So again, one thing to note here is I'm going through all the edges. I'm adding node from 0 to 1 and 1 to 0 both, right? So I'm just doing a pushback, and this add node method is very simple, that I have created. I have taken a iterator to find whether there is a node present in a graph. If node is not present, if node is present, that is iterator is not equal to end, then I'll just push back to the vector. So in place of here, I'll just mention it as a vector of int. And if node is not present, then I'm just creating a vector. I'm pushing back the 2, that is from and to the vector, and I'm adding it to the unordered map. So this is pretty simple. Now let me go to this. So the second part, the first part is creation of graph. The second part is finding whether there is a disjoint set or not. So to find a disjoint set, um, what what we are doing is we will be, so let me go back to my notepad. So let me consider that this is my input, and I need to find the disjoint set. So I'll be taking a visited, um, unordered set as of integer as visited. So I'll start from node 0 here, and I'll push into, so I'll be doing the depth first search. So the logic is I'll do a depth first search from node 0. I'll keep on adding all the nodes which are there in the visited, and uh, as I find a visited node, it means I have traversed this set. And now if the number of nodes which are there in the graph is not equal to the number of nodes in this visited set, then it means there is a disjoint set, right? So if I start from 0, I'll mark it in visited, like I'll place it in visited. So let me do it very quickly here. So I'll have my visited as 0. Then uh, as per the depth first search, I'll check all the neighbors of 0 which are not visited. I'll do a depth first search, so 1 and 2. And now I'll not find any neighbor of 2 which is not visited, so I'll come out of the depth first search, and now the visited size is 3, but total number of nodes are 5. So in that case, uh, we mean that there are at least 2 disjoint sets, right? So this is how I have done. I've taken an ordered set as visited, then I have pushed the first node on the depth first search, uh, popped out the first node, inserted in the visited, doing the depth first search in an iterative manner. And if visited size is equal to n, uh, that means there is no disjoint set. And if it is not equal to, then it means there is a disjoint set. So now, if there is a disjoint set, I'll be returning false. That's simple. Now in the third part, in the first part I have created the graph. In the second part I have checked whether there is a disjoint set or not. And in the third part I'll be finding a cycle in the uh, undirected graph using a depth first search and taking a parent. Okay. So for finding a cycle in the undirected graph, I'll be traversing through all the nodes. So this means that if graph has 5 nodes, for example, it has 0, 1, 2, 3, 4, 5. So I'll be traversing through all the nodes I have visited. So if present node is not present in the visited, so in that case I'll continue. Otherwise, I'll do a depth first search. So yeah, so one thing here, important thing to note is I'll be in the depth first search. I'm taking parent as an entry. So let me come up here. So why this parent is taken is that if I'm on a node, I should not check the node from where I am coming. For example, if I traverse to node 1, so it will check all the connected nodes to it. So it should, when it comes to node 0, that was from where I was coming, its parent. So I should do not check it, right? So this is the condition here that if parent is equal to neighbor, so in that direction I should not move, right? So again, this is a simple depth first search. So I came into the node, I added into the visited. Then I'm just finding node in the graph. So I'm just checking all the neighbors. So if I'm not at node 0, it will have the parent as -1. So on the first neighbor, that's 1. So this condition is not hit. This condition, that is, if I'm able to find neighbor in the visited, no. So in that case, it will go to the depth first search. Now it will come to depth first search of 1. So for 1, it has two neighbors, 0 and 2. It will find that the parent from where I'm coming, because I have passed 0 here. So it's 0, so it will continue. Then it will come to neighbor 2. So here on the neighbor 2, it will find that this is still not in visited. So it will initiate a depth first search for 2, and like for the depth first search of 0, 1, and 2, it will keep on inserting it. So this is the way we find um, wa- we find cycle in the in the undirected graph. So here it says that if cycle is found in an undirected graph, if it returns true, then we have to return false. And if we are not able to find any disjoint set and we are not able to find any cycle, then in that case we are going to return true. So this is how the graph algorithm goes like. If I check my submissions, it's accepted. So this is the solution. And yeah, on the time complexity and the space complexity. So for the time complexity, if we have v vertices and e edges, so for example, 0, there are v's 5 and edges is 3, right? So 3 edges per node. So for creating the graph, we are having OV because we are going to each of the edge and we are just creating. Uh, we are just going to every node and we are creating the graph. So it should be O V plus E rather. Then for finding the disjoint set, it's OV. And for finding a cycle in the directed graph, uh, this one is here. So for finding the cycle in the directed graph, it's OV plus E because we are only traversing every node once. So overall time complexity of this algorithm is OVE. And similarly for storing, the space complexity is OVE. Why OVE? Because we are storing, if we see here, we have v vertices, that is 4 vertices, and we have max number of 3 edges or neighbors. So it will be 4 into 3 something. So max number of edges into number of nodes. So this is OV plus E, OV into E. So that's all guys for this graph validity problem. Um, Thanks a lot. See you later maybe.